So welcome to the Unit 2, Lesson 8 video on complex number operations. So in this video, we're just going to do different operations with complex numbers. We'll do a little bit of addition, subtraction, some multiplication, and some division. And then at the end, we're going to take a look at some properties, and we'll kind of do an algebraic proof to give you just a little reminder of geometry. All right, so we'll start here with complex number operations of addition and subtraction. So the first example I have here has to do with the square root of negative 64 plus the square root of negative 9. So remember from the last video that the square root of negative 64 is really 8i. And the square root of negative 9 is really 3i. So when I convert these to complex numbers, imaginary numbers, I can then look at 8i plus 3i, which gives me 11i. So then we can look at addition and subtraction of complex numbers. All right, so when I have, this is an expression, 7 minus 2i minus negative 3 plus 1. So remember that when it's subtraction, the parentheses are important because you're going to distribute that. So I'm looking at 7 minus 2i plus 3 minus I. And now, again, we're going to combine like terms. So 7 plus 3 gives me 10, and negative 2i minus I gives me negative 3i. So I can simplify that to 10 minus 3i. Pretty straightforward. Addition, subtraction. So why don't you go ahead and pause the video and try problems number 1 and number 2, and then unpause the video and check your answers. Alright, so pause the video. Okay, so you see here problem number 1 has negative 11i, and problem number 2 you should get 2 plus 7i. And that's addition and subtraction. Remember, you're just combining like terms. And let's take a look now at multiplying complex numbers. So again, here we see this square root of negative 9. So we're just going to simplify that to 3i times the quantity negative 3 plus 2i. And we'll distribute that 3i. So we get negative 9i. And then when I multiply the 3i times the 2i, that gives me positive 6i squared. So that takes us back into that I squared issue, and I is the square root of negative 1. So the square root of negative 1 squared is negative 1, which is going to make that a negative 6. So I end up with negative 6 minus 9i. Notice I keep putting the whole number, the real number, first, and the imaginary number secondary, and that's just kind of standard notation. Probably wouldn't count off if you put the negative 9i minus 6, but you should try to write it in a standard form. So the second example here, we have a binomial times a binomial. So again, you're going to kind of double distribute that, and I like to use the area model to help me to organize my information. So negative 2, positive 3i, negative 5, positive 2i. So this gives me positive 10. This gives me negative 4i. This gives me a negative 15i. And this would be a positive 6i squared. But again, I squared, all that's going to do is change your sign to a negative. So this ends up being a negative 6. Now I have like terms here, which is 10 minus 6. So I get 4. And I have negative 15i and negative 4i. So that gives me negative 19i. And that's what you should end up with after you multiply these two binomials together. 4 minus 19i. So go ahead and attempt number 3 and number 4 by pausing the video, work through the problems, and then check back and we'll show you the answers. Alright, pause the video. Okay, so answer to number 3, you should have 1 plus 8i. And the answer to number 4, you should get 5. Now, this is kind of an interesting aspect. We started off with a complex number with some imaginaries in here, and we ended up with a real number with no imaginary. So these are actually called conjugates. So 2 minus I and 2 plus I are conjugates of each other because when I multiply them together, I end up with a real number. So a conjugate pair will have, it'll be a binomial, right? And so 2 minus I, 2 plus I. So another conjugate pair, let's say I had 3 minus 2I. The conjugate pair to 3 minus 2I would be 3 plus 2I. So again, just to refresh your memory on conjugates, those would be conjugate pairs. If I multiplied them together, I would get a real number. So this is very, very important for our next operation here, which are dividing complex numbers. So when we divide complex numbers, we use conjugates to rationalize or simplify each quotient of complex numbers. So when I'm looking at this first problem here, this first example, I see 9 plus 12i over 6i. So the first thing I'm going to do here is simplify this because I see that there's a GCF in each of these terms. So I'm going to divide each one by 3 and end up with 3 plus 4i all over 2i. Now, what's nice about this problem is that it's a monomial down here. There's only a term 2i. So what's easiest to do is just to multiply it by a negative I on top and bottom, which is just a product rule because negative I over negative I is 1, and multiplying by 1 gives you the same value. Now, the reason I'm only multiplying by a negative I is kind of because of the GCF. If I multiply by a 2i, then everything's going to be multiplied by 2, which then I'll have a GCF of 2. So to kind of simplify it, all I need to do is get rid of the I aspect, and I'm going to make it a negative so that I get negative 3i minus 4i squared all over negative 2i squared. So now you can see why it was a negative I, because this becomes a 4 minus 3i all over negative 2i squared just becomes a positive 2. And so I end up with 4 minus 3i all over 2. So again, when it's a monomial, simplify if you can, and then you're just going to be multiplying by a negative I over negative I, and you do that every time. Whereas here, in this problem, we have a binomial, so we have a real number added or subtracted by an imaginary number. So here we're going to have to really use conjugates. So the conjugate of 1 minus 4i is 1 plus 4i. But again, we'll do that on top and bottom so that I get 1, and I can use the identity property of multiplication to multiply. So again, division is a grouping symbol, so we can add these parentheses in here. And we're going to multiply the top times the top and the bottom times the bottom, just like when you multiply fractions. So first one's a little harder because we don't know what it's going to be. So we'll set it up here and see what we get. So again, this is 2 minus 12, so that's a negative 10. And this is 3i plus 8i, which is plus 11i. And that is my denominator. Now again, this is a difference of terms. So when I multiply those together, I'm going to get first term times first term, which is 1, minus the square of the second term. So that's a negative 16i squared, so that's a plus 16. So what's nice about conjugates is you should always get the first term squared plus the second term squared, because that's always going to give you an I squared, which will always change the minus to a positive. So we end up with negative 10 plus 11i over 17. The more you practice that, the better you'll get at it. But until then, if you want to go ahead and multiply it out until you start to get the feel for the pattern, that's fine. Just draw it out and multiply it. So they cancel out, and again that becomes 1 plus 16, which gives you your 17. Alright, so again, pause the video, try these next two questions, and we'll go on from there. Alright, pause the video. Okay, so for problem number 5, you should have ended up with 1 minus 4i all over 6. If not, check your work here, see what you did wrong. And for number 6, you should end up with 7 minus 26i all over 25. Again, if you had any trouble with this, check your work. Again, I didn't multiply the 3 plus 4i and 3 minus 4i out because I know it's a difference. So it's 9 plus 16, which is 3 squared plus 4 squared. And that's kind of the pattern that you should always see. But if you need to multiply it out, go ahead. Alright. So the last thing we're going to cover here is just justifying steps in an equation. Okay, so if you remember back in your geometry days, we'll look at a step, we'll tell why we know it's true, and we'll give a reason or a property that justifies our step. We're always kind of a step behind when we're justifying, right? We do the step, then we justify. Now if you also notice on mine, I had to write this in because it wasn't on my screen, but your paper is fine. So we'll start up here. The first thing I would do here would be to multiply these together. The property that allows me to multiply a binomial times a binomial is called the distributive property. So I don't want to see anybody write FOIL or multiply. We are using the distributive property to multiply two binomials together. So then the next step here, we switch our I squared to a -1. That is substitution, because I squared is the same thing as -1. Alright, and then from this step here where I have -3 times -1 and I get a +3, that is the closure property. So the closure property is just kind of like a simplification. When you're completing an operation, you'll use the closure property. Alright, and then our next step here is to rearrange the problem. So when you rearrange, that's called the commutative property of addition. And then we are going to put this 4 plus 3 into parentheses, and that is the associative property. And the last step here, we are completing the 4 plus 3 to get 7. So again, that is the closure property. Okay, so here we have another one, and I want you guys to try this one on your own. So pause the video and then try to provide the justifications for each step in this process. Alright, so pause the video and I will work this out for you and show the answers when you come back. Okay, so hopefully you were able to complete this and you have it all right. Distributive, commutative, associative, closure, and then this property here, which we didn't have in the last one, but you should know that anytime you're adding 0, that's the identity property of addition. Now you could multiply by 1, and that would be the identity property of multiplication, but adding 0 is identity property of addition. So you do need to tell me of addition to differentiate between addition and multiplication. Alright, so hopefully you were able to complete this correctly, and if you have any questions, we will talk about those in the beginning of class. So see you in next class.